Good evening, everyone, and welcome to our tutorial or revision for our course LET 212 Microcontroller. So, in this evening, I will be going first to discuss the topics in the morning that we met about algorithm, assembly language program, and simulation. And then you can also ask anything about the lesson for today. And after that, I will be showing you another one for the C language. So we will do revision of writing the algorithm and the C language program and simulation also with the similar problem but using C language. And after that, I will be doing a tutorial on Arduino Uno, and I will also accept questions about your projects. If you have any problem, maybe we can solve it tonight. And then tomorrow, you can also come to the office to ask me about some concerns. So in the morning, we have this problem about an active low green LED, and this is connected to P1.0. And this green LED, you have to take note, is active low. So when we say active low, what's the meaning of that? Active low. It means that when you put 0 to the LED, then the LED will be on. And when you put 1 to the LED, the LED will be off. So as you can see in this circuit, we have the P1.0 connecting the green LED, and we will turn it off after some delay. And to do that, we have to prepare, of course, the algorithm, and then followed by the flow chart, followed by the program. But I did not show you the flow chart anymore because there's another video for drawing the flow chart.
Yes, yes. Now it is.
Yes. Now, if I play like this, now can you see it? It's
Yes, yes.
doing the one by one. Can you see?
Yeah, one by one.
Yes. Okay. So declare the variable, set the origin to 00008 main, turn on, call the delay, turn off, call the delay, jump to main. This is the third time that you see this. Now I hope you understand. This is not easy. This is very hard. The assembly language. So we are here now. My question is, you see the whole screen now,
Yeah, yes, yes.
everyone? Now, my question was like this: what's next here? What will you put here in this part? What will you put? That's my question. So this is R5, this is R6. What do you think will be next? See,
R7.
R7.
R7. And then here again, D2, D2. So what will you put here? That's my question.
D2.
D1.
D1. What do you think will be next? Decrement. After that, we have to return. Huh? And when you say return, you know what will happen when you say return? You will be going back from number 15, and it will go to the calling statement, which is this. Remember, we turn on the LED. After you turn on the LED, we have to make a delay. So from number 5, it will go to number 9. And then from number 9, it will go to number 10, it will go to number 11. After that, it will go to number 12. After number 12, it will not go to number 13. Why? Because the R5, which is 100, must count from 100 down to what? 0. And how will it do that? We will subtract 1 from the R5. So number 12, how many times will we do number 12? How many times? Tell me. How many times will we do number 12? Is it 40 times, 100 times, 10 times? How many times will we do R5? If it
100.
100,
Anytime.
okay? It's clear, 100, huh? And then after 100 times, how many times will you do number 13? Let's see number 13. You will subtract 1 from R6. If R6 is not yet 0, you will go back to D2. So you will go back to number 11. So that's what will happen. So how many times will you do D2? Hmm. How many times?
100.
100 times. But what will happen? You will do you will do D2 100 times, and will be done 100 times every one time of D2. And If you reach 0, it goes back to D2. Let's say you finish, it will go back to D2 when it's not yet 0. Let's say you already reach 0. If you reach 0, then it will go to number 14. Okay? And then, after that, 14, you go back to D1. Number 10, when? When the R7 is not yet 0. So, what will happen here? Number 12, you will do it 100 times. Number 13, you're supposed to do it also 100 times. And every one time that you do it, you go back to 11. Of course, if you go back to 11, you will also go to number 12. And then you will do number 12 100 times again. What will happen here? R5, or again, will be done 100 times. And every 100 times of R5, it's only one time of R6. So if R6 will do 100 times, R5 will do 100 multiplied by 100. How many is that? That will be 10,000, right? And then every 100 of R6, you will do 1 of R7. So R7 will do the steps 40 times. But R6 will do the steps 100 times. And R5 will do the steps 100 times also. But when you multiply the 3, 40 multiplied by 100 multiplied by 100, the total will be around how much? 400,000 maybe, right? So this will do the delay 400,000. But what I'm telling to you is you don't need to explain that. Why? When you write the program, you just need to write the not program, the algorithm. You don't need to explain, you don't need to worry. What do you think will be next after 15? What's next?
End of the algorithm.
End. Yeah, end. It's correct. End of the program. That's it. This is easy, this is easy, this is easy, this is easy, 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 easy. How about number 8? Jump to main. Is it easy for you or no?
Yes.
There's main. After main, there's jump to. How about this? Return. Is this easy for you? Yes?
Yes.
Just right. How about this? Of course, end. Is it easy?
You
Mhm.
have B10 and B11. We
If
will.
the question is P10 and P11,
Yeah.
is that your question? Oh,
Yes.
you answer the question. You answer your question. What will you do here? What if there is P10 and P11? Or what will you do?
Declare B10 and B11.
Yeah, but you have to put it in another line. Huh? You have to
Yes.
put in number 2. In number 2, what will you put in number 2? Declare
Declare
P11 variable as P1.1.
one.
And do you think only one? I can ask you 0, I can ask you 1, I can ask you 2, I can ask you 3. Am I correct? I can start with 0.0. What's the last? 0.7. I can start from 1.0. What's the last?
7.
1.7. I can ask 2.0. What's the last? 2.7. I can ask 3.0 up to 3.7. So total, how many pins can I ask? I can ask you 32 pins. How many I ask here? How many?
1.
Only one. So let's say I ask you 8 LED. Is there a problem? If I want you to toggle 8 LED, is there a problem?
No.
What will you do? It's only longer. It's only longer because here you will write here 8 times. How about number 2? How many times will you do this? One time. How about main? How many times? One time.
Uh,
How about turn on the LED? How many times will you do turn on the LED?
8 times.
8 times or more marks for you. How many times will you call the delay?
Uh, 16
Think.
maybe.
No, one time. One time. Because what will you write here? Turn on the first LED. Turn on the second LED. Turn on. You understand? After you turn on
Um,
8, you can also make it one word. What's the one word here? Turn on all the LED if you want. Okay, so what else? Question. You ask me. Hmm. Any other question? Hello? So it means no question, huh? Or if you have no question, I have a question. Shall I always put this or I can change this? Can I change 40, 100, and 100 or no? Hello?
Yes, it could.
You could, huh? Do I care whatever number you put here? Do I care? I don't care. Why? Because the in the question I did not say how much is the delay. So if you make your delay impossible, like it's like microsecond or millisecond, because you only put 111 or 123, it doesn't matter. As long as it will not be more than what number? Not more than 255. Okay? So that's it. All right. So about the program, this is the program. Any question here in this? Do you know P10, right? Because that's in the question. What if there are two question, not only P10? Or you put another one on the next line. How about bit? What do we use in C language? Is it bit in C
It's good.
language? S bit. Don't forget, huh? How about in C language? Do we put P1.0 in C language? I think we put P1 caret, isn't it? 0. And then semicolon, right?
Yes.
But here, you put P1.0, which is more easy for you. P10 equals P1 caret 0 semicolon, or P10 bit P1.0, or they are both easy, or assembly is more difficult. Which one do you think is more difficult? Maybe assembly, because this is the second time that you do it. Unlike C, you do it more than 10 weeks. Okay, next, org 008. So tell me, is this easy or difficult? This one, tell me.
Easy.
Easy. How about this, main? You will
Yes.
just write main. Easy. Next, CLR P10. Oh, maybe you will say difficult because maybe you will forget the spelling CLR. What do you think? Is CLR easy or difficult to remember? CLR. Huh?
Easy.
Maybe because
Easy.
maybe because I write look in memorization. Sometimes you have to exaggerate. It means you have to think big. Like now, I will write C, I will write big letter L, and then I will write big letter R. Look at this. Is this a small letter or very big, right? Oh, maybe because of that, you will never forget anymore the letter C, letter L, letter R. And after 3 weeks, you still remember CLR. Try it. After today, check tomorrow if you can write CLR. But what will this do? This will make P10 equals to 0. And then what? Call delay. And then what's next? Tell me. Now, let's go ahead with the jump main. What do you think about jump? Do you have problem? Maybe because we don't put letter U. What's the spelling of jump? J-U-M-P. Here, we only have 3 letters. Okay? 3 letters, J-M-P. And what will this do? It will go back here. Okay, next, we have the delay. Oh, this one new. You see this one new? Oh, it's 8:45. We only have 30 minutes. Don't worry, I will do another one after tomorrow. This one, move R740. I think this one may be difficult for you, but this is like in C language, it's like R7 equals 40. So the position, the 40 will go to R7, but you have to use the word move. You remember the 3 numbers that we need to put? What are the 3 numbers? 40. What's the next? Tell me.
100.
100.
100.
100.
You look. I hope this tutorial is helping you. Huh? And then what's the next? There's 3
100.
numbers. Another
100.
100. Inshallah, you will get A plus. Huh? Oh, 40, 100, 100. And then don't forget R7. You see this? R7 followed by R6 followed by R5. Do you want to use the same or you want to change it? Or I cannot change it. Can I change this? Yes, you can. You can use number R4, R3, R2. Okay? You can make uh, 7 up to 0 only. Huh? These are the registers. But of course, if you don't want to be confused, why will you change, right? Use the same R7, R6, R5. In other words, if the question for you is some delay, are you getting my point? Do you understand what I'm saying? If the question for you is some delay, you do this, isn't it? Okay? And then you also need to write this because this is together. You have to write that. Now, all right. So do you have other question? Return and then end. Question about the program. I will erase.
But I
You use
mean,
the same.
why do we put only two?
You can
Only
put
two
more.
values.
You can put D1, D2, D3, D4 if you want your timer to be longer. Actually, in the book, some examples it's only using one delay, but the blinking of the LED will be very fast. So they use another delay, but it's not using D1. They are using L1, L1. But original from me, I use D because I'm using delay, so I use D. But you can put D3, D4, D5. But if you do that, the maximum you can do is only 8, from R7 to R6, R5, R4, R3, R2, R1,
Also,
R0.
yes.
But why will you do that? You will make the delay so long, so long. To make your delay longer, you can put here 100 or 255, maybe 200, 200, 200. But this is not really a big issue. You like obey one, obey two.
No, delay is better. Yes.
Oh, actually, what I said, you can you can change this to letter D, right? And then you can make this letter A. You can make this not A1. You can make this A2, and then you can make this hello. No problem. But you will also make this hello. And what will I write here? Tell me.
A1.
Not
A2.
A1,
A2.
A2. What will I write here?
A1.
A1. What will I write here?
Call D.
D. Oh, which one is easy for you? If I don't have any more, I want to finish the question early, I will just use letter D. For example, main. What's the shortest we can use for main?
We cannot get it any shorter.
M.
It's
We
M.
can use M. Okay, we can use M. Now, I'm not sure now if we do one letter, if the assembly will accept one letter for the label.
Mm.
So you better use at least two letters. For example, MN. And then here, I will put MN. And then here, I will put D. Look at my program now. And then here, I will put he. And then here, I'll put he. And then here, to make it easy, I will make it 50, 50, 50. Understand? Okay?
Yes.
And of course, you have to align your solution so that it will look easier to understand like this. Org 00, you can cancel the 30. Let's make this very easy. P10, what's the color of the LED? What's the color of the LED? Green, right? Green. Okay. I'll put G. For the LED, I'll put G because it's green. Okay. And then I will put here clear G. And then here set BG. Oh, what do you think? Is it getting easier or more difficult? Look at the program now. Is it more easy to look or more difficult? Tell me.
No, it's easier.
Oh, you see? You see? Now, if I in the assignment, I give you green, yellow, and red. Oh, I did not give you the assignment yet. Last assignment. Oh, what do you put? Green, yellow, right? Green, yellow. Oh, what will I put? Green, yellow, and red. But if there's two red, oh, you put red one and then red two. But if you're confused, what do you do? Don't do this. Put P10. What else? P11. What else? P12. Correct? P13. Oh, let's say, I want you to, comment is semicolon. I want you to turn off active high LED. How will you do that? If you want to turn off an active high LED, what's the solution? Let's say the LED is P10,
Equal
active
0.
high. How will you make it off?
Equal 0.
Equal 0. Okay?
Yes.
But if it is active low, how will you make it off? Active low. How will you make it
1.
off?
Equal 1.
You put 1. Equal 1. But this is C language. C language. So, to put 1, the command set B. Okay? Set B followed by the P10. This is the command. Like this one. You see this? What is this doing? Set B G. What is it doing? It's doing what? It's doing G equals what?
0.
No. No.
It's active low. 1 equals 1.
No, 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 no. There's no active low. Set B means 1. And then it's always 1. Clear means 0, huh? Don't forget. You see, that's why we have revision. Okay? So, let's say I want to make P22 equals to 0. What will be the command? Tell me. Will you use clear or will you use, what's the other one? Set B. Which one will you use? So, what's the answer? P22 equals 0. Okay. Set B, P22. Clear? But again, I don't want to confuse you too much. So I hope you understand the two program. Now, the difficult part is the timer. Okay? So, number 1, is there a problem with number 1? Or you're okay? Are you okay with
Okay.
number 1? You're okay. It's the same, right?
Yes.
Number 2. Just say yes. Number 2. You're okay with 2? Yes or no?
Yes.
Yes. Number 3.
Yes.
Yes.
Number 4. Number 5. Number 6. Number 7. Number 8. Number 9. Only up to number 8. Oh, are you okay?
Yeah. That's good.
No. Maybe no. Because this one changed. See that change? See that? Why? Because I asked timer 1 mode 1. A question. Can I only ask you timer 1? Or I can also ask you another question? Yes or no?
Question.
What question can I ask you if it is not timer 1?
0.
Yes. Anything else? Can I ask timer 2? No, no. Timer 2, we don't have. Mode, we can change. Oh,
Yes.
for the mode,
Zero and
how many modes we have? Mode 0, mode 1, mode 2, mode 3, correct? Isn't it?
Yeah.
But what's
Yes.
the example that we always use? Only mode 1, right? That's what we always use. Yeah? But in assignment, I gave mode 0. If it is mode 0, it cannot be 4B FD, right? This is only for mode 1 and this is only 50 millisecond. For mode 0, I think I gave that before, but I forgot the number. But you have to calculate for a new one. But anyway, let's say what you have is mode 1. This is the solution. Now, number 9, you write the delay. So before, I only write delay. Now, I write T1 M1 delay. So the spelling changed, only the spelling. But this will call this one. So what's number 9? Is it difficult? Maybe. Because before, it's only delay. Now, it's T1 M1. Number 10, look, R7, this one. Before, we put 40, right? Remember, the 50 milliseconds, when you think about it, it's not 1 second. But in the question, here, we're supposed to read the question, 1 second. We need 1 second. And we multiply 50,000 microsecond by 20, that will be equal to 1 million microsecond. That will be 1 second. Therefore, you have to remember 20. Okay? So what is 20? How long is 20? 1 second. 20 times multiplied by 50 milliseconds, that will be equal to 1 million, sorry, 100, how much? 50 multiplied by 20 will be 100 100, am I correct? 1,000 millisecond, 1,000 millisecond, that's 1 second. That's why we multiply by 20. Let's say I ask you 2 seconds. What number will you put here? 2 seconds.
200.
No. Again. 20, 1 second. How about 2 seconds?
40.
Oh, you see? Is it easy or difficult? Oh, what if I give you difficult? 3.5 seconds. Oh, 3.5 seconds. What number will you put? 20? No.
60.
40?
65.
65? No.
60 maybe. Because it's
Look,
20, 40, 60.
no. Look. 20 is 1 second. What
Yes.
is 10? What is 10?
10, it's half.
Oh,
So
so
0,
if I
0.5
want,
second.
so 0.5. Oh, what is 3.5? Second.
Uh,
65
no.
or 70?
It will be
65 or 70?
70. I don't know. 1 minute.
20, 1 second. Another second, 20, 2 seconds. Another second, 20, 3 seconds.
Total is
Half second, 10. Oh, add all. How much?
70, right, right.
Oh, you see? So you will make this 70. Oh, let's make it more difficult. 4.25 seconds. Oh, tell me, what number will you put? 4.25 seconds. Come on, we only have 8 minutes left. Oh, 4 second. How many is 4 second? Is it 20? 20, 20, 20, 20, right?
Yes,
10,
that's 80.
10,
Uh,
10, 10 is half second. This, oh,
5,
what is 5? Oh, so how much total?
85.
85. Oh, here, you remember WTT, remember that?
Yes,
T mode, TL, TH, TR, while TF1 equals 0, do nothing, and then TR, and then TF. Remember, you can write the same. You can write, make the T mode T1 M1, timer 1 mode 1. Make TL1 equal to FDH. You can write like that, no problem with me. But look, these are standard in, wait a minute. Okay, any question here in the timer? Actually, this is so hard. The timer is so hard if you have trouble with the C, right? If you have trouble with C language, you will have trouble with assembly. So if you're not good in C, how will you be good in assembly? Because you will not have any reference to C. C language, what we do, remember, look at this. T mod, TL, TH, what else we put? T mod, TL, TH, TR, TF, TR, TF, right? So and the TF, this is where we put while. Remember this? TF, if it is timer 1 equals 0. Remember this one? This is we are doing this too many times already. Remember this? Equals 1 1 1 1 1, and then this will be equal to 0x. This is equal to 0x. This is equal to 1. What's this? Equal to 0. This is equal to 0. And then if you want timer 1, mode 1, 1 0. And then here we put FD. We don't put H, huh? And then we put here 4B. Remember this? Can you write this or no? Tell me. Can you write this in C language?
yes.
Yes? If not, you have a problem, because if you cannot write this in C language, then how will you write it in assembly? Because you look, if I will write this in assembly and I'm writing the algorithm, what will I write? I will write here, make tmod equal to 1 0. It's okay. Here, what will you write here? Make TL1 equal to FD, hexa. How about here? You understand? This you can write here in the algorithm, because these are just algorithm. But when you write the program, of course, when you write the program, it will be different. Look, P10 org clear call clear set B call. Look, see move. You will use the word move. Move tmod 10h, move TL1 0 FDH. Remember, there's someone who asked me put 0 here. Oh, what's the answer? Why we put 0 here? Why? If the hexa is a letter, you remember in the morning I told you that? If the hexa is letter, you put 0 in the beginning. How about the other hexa? Look, what's the other hexa? 4B. It does not start with letter B. It starts with number 4. But if the hexa is CD, oh, what will you write? CD. I will write 0 in the beginning, and then of course you have the hashtag or hash followed by letter H here. That's what you will do. We always put 0 if the hexa starts with letter A, letter B, up to letter F. Like here, it starts with 0 because the one here is letter F. Okay, enter. You have the set BTR1, JNB, TF1, D2. So this is new, this one. But what will this do is it will just, you remember this one. I'll show you. You remember while this one, while TF1 equals 1 equals 0. You see this? That's the meaning of this JNB TF1 D2, because it will just go back to to D2 while the TF1 is not yet, is still equal to 0. But if it is now no longer equal to 0, maybe it's equal to 1, going to the next line, which is clear TR1, clear TF1. But remember, this is already the assembly program. Let's look at it. So in the timer assembly program, look at it. It's not very long, right? It's not very long. It's short. Let's number the first, the second, the third, the fourth, the fifth, the sixth, the seventh, number 8, number 9, number 10, and number 11. I hope that's easy for you, right? How many lines easy for you? 11. Maybe this easy also for you. 12. The only problem, this part. But if you are good in C language, you know Tmod, TL1, TH1, TR1, TF1, TR1, TF1. You have to write all of this. How many? 1, 2, 3, 4, 5, 6, 8. Maybe you will be wrong here. You don't know. You need to put move or you forgot the hashtag. But anyway, in total, is this 60% or is this more than 60%? I think it's more than 60%. If you count the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, you have 13 correct. And then 1, 2, 3, 4, 5, 6, 7 wrong. What we want is you understand one LED, then you can do any LED. You can do 2, you can do 3, you can do up to 8 LED.